Dear students, now we can solve some problems regarding electric potential. In the last class, we discussed 6 questions. The 7th one, two charges 3 into 10 raised to minus 8 coulomb and minus 2 into 10 raised to minus 8 coulomb are located 15 centimeter apart. At what point on the line joining the two charges is the electric potential zero? Take the potential at infinity to be zero. So here two charges are there with a separation of 15 centimeter. We have to find what is the location along the line joining them where the potential should become zero. So we can apply the superposition principle. So at the point P, what is the contribution of electric potential due to O plus the contribution from A is equal to 0. So the contribution from O is 1 by 4 pi epsilon 0 into 3 into 10 raised to minus 8 by the separation denoted as X plus the contribution from A, and here it is with the minus charge, minus 2 into 10 raised to minus 8 by the separation. From O to P we take as X, and hence the separation AP is 15 minus X. So it should equal to 0. So we can take this term because of the minus sign to the right hand side. You can cancel the same factors. Then you get the value as 3 by X is equal to 2 by 15 minus X. And keep in mind here, X, the 15 minus X are in centimeter. So just to cross it, 3 into 15, 45 minus 3X equal to 2X. So you can take that 3X to right hand side, you get the value 45 equal to 5X. And hence you get the answer as X is equal to 9 centimeter. So here we apply just our superposition principle. But potential is a scalar quantity, and hence we take just the algebraic sum. Next question, number 8. A charge Q is equal to plus 1 microcoulomb is held at O between 2 points A and B such that AO equal to 2 meter and BO equal to 1 meter, and is shown in figure. Calculate the value of potential difference VA minus VB. What will be the value of potential difference if the position of B is changed as shown in figure B? So we can just go through the figure at first. See, so it is given that plus 1 microcoulomb is placed at O. The A point is at a 2 meter gap and B point with a 1 meter gap. So at first we can just find what is the potential difference between the points A and B. We want to find what is VA minus VB. You know, due to a charge, what is the contribution? It is so simple as 1 by 4 pi epsilon 0 into Q by separation. So the potential difference can be written as 1 by 4 pi epsilon 0 Q into the location of A from O. So AO minus 1 by this location as OB. You know, 1 by 4 pi epsilon 0 as a 9 into 10 raised to 9 into the charge given as 1 microcoulomb as a 10 raised to minus 6 into 1 by, it is given as AO as a 2 minus 1 by BO as 1. So 1 by 2 minus 1, it becomes minus half. 2 and 9 cancel. You get the value 4.5 into 10 raised to 3 volt with the negative sign. We already know one thing. The electric potential is a scalar quantity, and hence if we change the location of B without changing the separation, then there is no change in potential difference. Reason, the potential is a scalar quantity, and here the separation is constant but the direction only is changes, and hence there is no change with the potential difference. It is a very good concept. We can move to the next question, number 9. Two charged particles having equal charges of 2 into 10 raised to minus 5 coulomb are brought from infinity to within a separation of 10 centimeter. So here the two charges having values 2 into 10 raised to minus 5 coulomb are taken from infinity to a separation of 10 centimeter. Find the increase in the electric potential energy during the process. You know one concept, the electric potential energy at infinity separation is 0. Then surely the increase in potential energy means the potential energy at this separation within a separation of 10 centimeter. But it is so clear for you as 1 by 4 pi epsilon 0 q1 q2 by r. So 9 into 10 raised to 9 into the two charges by the separation. The separation should be converted into meter. So 9 into 2, 18 into 2, you get the value 36. The powers cancel. So that is answer. So already you know the electric potential energy is nothing but the work done to assemble that configuration. So that is a concept we used here. Then we can move to the next question, number 10. A good question, a good aspect. The two particles have equal masses of 5 gram each and opposite charges of 4 into 10 raised to minus 5 coulomb and 4 into 10 raised to minus 5 coulomb. They are released from rest with a separation of 1 meter between them. Find the speeds of the particles when the separation is reduced to 50 centimeter. So here two equal and opposite charges are given with a separation of 1 meter. You know, they are with opposite charges. So while releasing, surely they will attract, then come closer. But we have to find what is the velocity of them if they are within a separation of 50 centimeter, 0.5 meter. So here the increase in kinetic energy is nothing but equal to the loss in potential energy, the final potential energy minus initial potential energy. And here the two masses are there, and hence their increase in kinetic energy means 2 times of half mv square equal to 1 by 4 pi epsilon 0 q1 q2 into the final position 1 by r2 minus 1 by r1. So 2 cancel. The mass is 5 gram. So 5 into 10 raised to minus 3 into v square equal to 9 into 10 raised to 9 into. They got the same values with opposite signs of 4 into 10 raised to minus 5 the whole square into 1 by the separation. The final separation is 0.5 meter. So 1 by 2 minus 1 by 1. So that is a 2 minus 1. So 9 into 4 square as a 9 into 16. 10 raised to minus 10. 10 raised to 9, so 10 raised to minus 1. So you can give to the right hand side that 5 into 10 raised to minus 3. Then we get the answer as V is equal to 53.7 meter per second. So here we use the concept, the increase in kinetic energy is a loss in potential energy. So the mechanical energy conservation there. So that is a very important concept. Look at the question number 11. Calculate the electric potential energy of the system of charges as shown in figure. Plus Q, minus Q, minus Q. The side are given as A. Before solving this question, we know the simple concept for the two particle system. The potential energy of the system is 1 by 4 pi epsilon 0 Q1 Q2 by the separation. But here it's a 4 particle system. So how much number of contributions are there because of this 4 contributions, 4 charges? So how much number of contributions are there? So we can easily find how much pairs are there. So here the 4 particle system, we can use a simple shortcut to find how much contribution, how much number. It's a 4 particle system, means n into n minus 1 by 2 number of pairs are there. That means 4 into 3 by 2, that is equal to 6 pairs of potential energy contributions. We can visualize them. So here the 1, 2, 3, 4 charges. So we can take that 1 and 2 together as one system, 2 and 3 the next, 3 and 4 the next, 4 and 1 as the next. Then again the corners 4 into 2, 1 into 3. So we can just written as the U12 is K into 1, 2. So QQ by A. Similarly, you can write the 2, 3 contribution, 3, 4, 4, 1. But they are with the equal separation, so hence we taken as A. But the diagonal contribution are a little bit different. So if you just find 1, 3, so Q into minus Q by, the diagonal separation is root to A. Likewise 2 into 4. So you just solve it, and there these factors are cancel each other, and you get the value K into, and they are equal, and hence minus sign 2 times Q square by root to A. So that is answer. So it's a very, very important type of question, not only for our board examination, but for our NEET JEE entrance exams. These type of questions are very, very important. Keep in mind. A similar concept is coming with the next question also. 4 charges are arranged at the corners of a square ABCD of side D as shown in figure. Find the work required to put together this arrangement. That question is so simple. That is our concept is what is the potential energy of the system. So simple. The second part, a charge Q0 is brought to the center E of the square. The 4 charges being held fixed at the corners itself. Then how much extra work is needed to do this? So in order to take that Q0 brought to the center, how much extra work we have to done? So it becomes so simple. At first we can go through the figure there. So here plus Q minus Q plus Q minus Q, the center point E. So at first we have to consider that ABCD charges only. So you know the 6 contributions are there. That's the 6 contributions we can analyze as between AB, BC, CD, DA. Then the diagonals AC and BD. So you can just substitute them. So here we get The first four contributions are equal, so minus 4 q square by d. The last, the diagonal contributions, they are equal 2 into q square by root 2d. So you just take minus q square by 4 pi epsilon 0 common, so 4 minus root 2. So that is the answer. So simple concept like the previous one. The next concept is how much extra work needed. The work needed is nothing but equal to charge into potential. So here the potential at E due to the other charges A, B, C, D. So the charge, we need to move that Q0 into 1 by 4 pi epsilon 0 into Q by separations. So here Q by, minus Q by, plus Q by, minus Q by, they are with equal separation. Already you know the diagonal is root 2d by 2. But here look at the numerator. Q minus Q plus Q minus Q becomes 0, and hence work done becomes 0. Already you know that point is equal from other four corners, and also pairs are equal, and hence they cancel each other. So the work done becomes 0 at the point capital E. Thank you.